Okay, so we're going to talk about we're going to talk about two things.
There goes a sight from my soul.
Ohm's law. First thing, we know that Ohm's law says V equals IR. So V is voltage. Volts. We have I, which is current. And R, which is resistance. Okay, so V equals IR, and you need to know that Ohm's law, okay, V equals IR is the relationship between voltage, current, and resistance inside of a circuit. Okay, so voltage and current have a relationship because of resistance, and resistance has a relationship with current because of voltage. All right, and let's just talk about it. What voltage is, current is, and resistance is. Okay, so say we have a hill. All right, I'm going to draw a hill. There you go. Draw a hill. Okay, and we're going to say that voltage, I'm going to draw it in black. All right, voltage, V, is the kind of potential energy, all right, that we have to work with. So say we have 12 volts. All right, the hill is 12 feet high, 12 volts. All right, and then we have resistance. We're going to say resistance is green, resistance. We're going to define these in just a second. Resistance. Okay, and let's say along the way there are some trees. Okay, they're resistors. Okay, and then at the top of the hill, we have these gray rocks. And the rocks are the only thing we have left, which is current, I, which is current. I is current. All right, so we need to know, first of all, that voltage is measured in volts, right? Resistance is measured in, guess what, ohms. All right, and it's drawn like this, okay, ohms, and the current is measured in amps, okay? All right, so say we have 12 volts and we have two trees that are gonna block the way. So it slows down the resistance, actually even stops some current from going through. So say these rocks start tumbling down, all right? Tumbling down, tumbling down, tumbling down. All right, and one rock gets stuck against this tree, and a rock gets stuck against this tree, and out the bottom, we have two of the original four rocks that went up the tree. All right, so resistors kind of suck current in. It shuts the hole of what resistors do, or what available current we have to work with from the voltage. All right, and I know that may sound confusing, but let's give these a formal definition real quick. Okay, so let's just talk about current real quick. Current is the amount of electrical charge that flows past a certain point in your circuit. Okay, so you're gonna have a different amount of current here than at the top because you have resistors that block it, and you have current drops that go on through LEDs and all kinds of stuff. You can lose current a multitude of ways, but so we have less current down here and more current up here at this point in our circuit, all right? And resistance causes current to drop, all right, to go down, all right? So let's talk about resistance. Resistance is how much a component, whether that component can be an LED, it can be a integrated chip, it can be a button, it can be anything. a component resists or pushes back the electrical flow. So how much it pushes back the current. All right, so this pushed back the current by getting rid of 2 rocks. All right, and then finally we have volts, and volts are the amount. It's the amount of potential force, electrical force, okay, electrical force that we have to use. All right, and that's Ohm's law, okay? It's not hard, it's not difficult. It just takes a little bit of understanding to see, all right, well, what does resistance actually do? It actually it causes the current to dwindle down. Well, what's the voltage actually do? Well, that's the amount of potential force we have. So at the end of the current, if we only have a couple of things that are taking the current down, if we only have a couple things that have resistance, then we don't need a lot of volts. But if we have a lot of things that have resistance, then we need more volts, right? The relationship, if there's more resistance, you need more volts, which has more current. Okay, does that make sense? If it doesn't, we can talk about it a little bit more in class, but I kind of want to move on to something else. We're going to start getting into reading schematics tomorrow. So I want to hit real quick something that I didn't want to talk about, schematic symbols. Okay, going back to Ohm's law, we know that we have voltage. All right, so I'm going to say the voltage is V. All right, and it's going to have a line underneath of it. It's actually going to say VCC. Okay, it's got a line underneath of it, and then it's going to start the current. Okay, the current flows through the wire. Okay, so current, and there'll be a little arrow the way that the current flows, just like that. All right, so then say we want to have a resistor, and a resistor is going to look like this. Resistor is going to look like this. It's going to be a squiggly thing that looks just like that. That's really big, but that's okay. All right, so that's what we got so far. All right, we have a VCC current, we have a resistor, and it'll have a resistance value with it. And then say we want an LED light bulb, and this is going to show you, I'm going to show you what an LED light bulb looks like. An LED light bulb. LED light bulb, okay? So we're going to be looking at these things, the voltage, a resistor, and light bulbs tomorrow. You're going to have to read these off of a piece of paper, and I'm there to help you. Okay, so say we're looking at this circuit, and we have a power source. Okay, that's actually the symbol for DC power. That means it's a battery. So say we got a 12-volt battery, all right, and we have a resistor here, all right, and a resistor here, both 220 ohm resistors. Okay, so we know that V equals I R. So we have voltage and we have resistance. So what do you think we're going to find? We're going to find I. We're going to find current. Okay, so let's see. V is 12, so 12 equals I. We don't know I, and R. And R, let's see. Okay, we have 2 resistors. So in a series circuit, we're just going to add them up. So in a series circuit, we're just going to add them up. We can talk more about this later, but we're just going to add them up. 220, 220. So we are at 440. Okay, so now we have an equation that we can work with. All right, so 12 equals I multiplied by 440. So we want to get I by itself, so we divide both sides by 440. Okay, those 440s cross out, and we divide this side by 440, and we get a really small number, that number. Okay, so we get that number. We get 0.027 repeating. Okay, so equals I. So 0.27 repeating equals I. All right, so, but we can't just say that, all right? We have to put I in form of amps, because that's what it is, in forms of current. Okay, so we want to say that it's 0.027 repeating amps. Okay, well, we don't even need the equal sign, amps. All right, so we have 0.027 repeating amps. All right, but yeah, that's cool, but what if I want to put it in regular notation? Okay, not a decimal. I don't want a decimal. I don't like decimals. All right, so I want to put it in regular notation. I can go ahead and I can say, all right, well, I want to move the decimal point this way, so I can say 27 milliamps. Okay, 27 milliamps of current. All right, so that's what we're getting to. Okay, this is what we're going to do, not tomorrow, but a little bit later on. I just want to give you an idea of how we're using Ohm's law and the relationship between voltage, current, and resistance to solve currents, all right, and solve circuits, and use the trees, all right, and the hill and everything else, all right, to understand that yes, the voltage here is 12, but right here it's going to be less. All right, right here it's going to be less. Okay, and the current's going to be less here than it is here. All right, so I mean it's there's a lot to learn, but this is where we're heading. That's it.